Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have two circles. Each circle is passing through the center of the other circle. So this is the center of this circle and this is the center of this circle, and the radius of each circle is equal to 5 units, and we want to find out the area of this green shape. So we will start with the first method. We will define the center of this circle as point P, and we will define the center of this circle as point Q, and we will define the first intersection point of these two circles here as point A, and we will define this second intersection point between those two circles as point B, and we will join together by a straight line points B and Q. Actually, BQ is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point Q, and ends at point B, that is a point on the circle itself. Therefore BQ is the radius of this circle, that is to say it equals to 5 units. We will join together points P and B by a straight line. Line segment PB is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point P, and ends at point B, that is a point on the circle itself. Therefore it is the radius of this circle, therefore it equals to 5 units. We will join points A and P together by a straight line. Line segment AP is the radius of this circle for the same reason, because of the fact that it starts from the center of this circle, that is to say from point P, and ends at point A, that is a point on the circle itself. Therefore it is the radius of this circle, that is to say it equals to 5 units. We will join points A and Q together by a straight line. Line segment AQ is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point Q, and ends at point A, that is a point on this circle itself. Therefore it equals to 5 units. So actually we created here a rhombus. A rhombus is a quadrilateral with 4 equal sides. So AP BQ is a rhombus, and we will join points A and B together by a straight line. That will be the first diagonal of rhombus AP BQ. And we will join together points P and Q by a straight line. This is the second diagonal of rhombus APQB. So we have two diagonals, AB and PQ are two diagonals of rhombus APBQ, and we know that the characteristics of the diagonals of a rhombus is that first of all, the diagonals of a rhombus bisect each other and they are perpendicular to each other. I repeat again, the diagonals of a rhombus bisect each other and they are perpendicular to each other. So here we have the rhombus APBQ. The diagonals of this rhombus, that is to say AB and PQ, bisect each other, that is to say we will define the intersection point between these two diagonals AB and PQ as M. So because of the fact that the diagonals bisect each other in a rhombus, it means that PM equals to QM. PM equals to QM, and they are perpendicular to each other, that is to say we will have here four right angles. Okay, according to the rule that the diagonals of a rhombus are perpendicular to each other, that is to say we have here four right angles. And we also know that PM equals to QM, but we also know that PQ is the radius of this circle. That is to say PQ equals to 5 units. It is the radius, PQ is the radius of this circle, because of the fact that it starts from point P and end, that is the center of this circle, and ends at point Q, that is the point of this circle itself. Therefore PQ is the radius of this circle, that is to say it equals to 5 units. And we also know that PM equals to QM, so if we define QM as X, then PM will be also equal to X. And we also know that PM plus QM, PM plus MQ equals to PQ, PM plus MQ equals to PM plus MQ equals to PQ, and PQ equals to 5 units. PQ is the radius, so it equals to 5 units. So here PM is X plus MQ, that is also X, equals to 5 units. So X plus X is 2X. 2X equals to 5. We'll divide this equation by 2, and we'll get that X equals to 5 over 2. So here we can write here that PM that equals to X equals to 5 over 2 units, and MQ also that equals to X, it is also equals to 5 over 2 units. Okay? And we have here in triangle AEMQ, if we define this angle as theta, so if angle AQM will be defined as theta, then if cosine theta will be equal to MQ over AQ, cosine theta equals to, in triangle AMQ, the right triangle, cosine theta equals to MQ over AQ, again in the right triangle, triangle AMQ, cosine theta equals to MQ over AQ, but MQ equals to 5 over 2 and AQ equals to 5. So in conclusion, we found out that cosine theta equals to 5 over 2 over 5, that is to say equals to 5 over 2 divided by 5. Here 5 over 5 is 1, so here we will get that it equals to theta, so cosine 5 over 5 is 1, so it equals to 1 over 2. So we found out that cosine theta equals to 1 over 2. If cosine theta equals to 1 over 2, it means that theta equals to 60 degrees. Okay, theta equals to 60 degrees. So we can write down here that theta equals to 60 degrees. Likewise, in triangle QMB, here, if we define this angle as angle theta, then cosine theta will be equal to 5 over 2 over 5. Okay, and according to what we have already found out, we'll get that theta also equals to 60 degrees. So this angle also equals to 60 degrees. The same thing here in triangle PMB, the right triangle, triangle PMB. Cosine theta will be also equals to 5 over 2 over 5, exactly like in the other two triangles. So theta will be equal to 60 degrees. And we get also the same thing in triangle APM. In triangle APM, cosine theta, this triangle cosine theta will be equal to 5 over 2 over 5, and theta will be equal to 60 degrees. Okay? And in the next step, we'll focus on the right triangle AQB. And the right in triangle AQB, this triangle, and triangle APB. In triangle APB, and we will prove that those two triangles, triangle AQB and triangle APB, can go into each other. Why they can go into each other? First of all, we know that AP equals to AQ equals to 5 units. AP equals to AQ equals to 5 units. And also PQ equals to QB also equals to 5 units. Okay, PQ equals to QB equals to 5 units, and AB is a common side, it belongs to both triangles, so AB equals to itself. AB equals to AB is a common side that belongs to both triangles. So we actually found out that triangle AQB can go to triangle APB according to side rule. Okay, we proved that all the sides of triangle APB can go into all the sides of triangle AQB, therefore those two triangles can go into each other according to side rule. Okay, and what is the area of sector AQB? The area of sector AQB the squared brackets here is the same for the area, so it means the area of sector AQB will be equal to pi r squared over 60 plus 60 is 120 times 120 degrees over 360 degrees. So we get that the area of sector AQB, this sector, will be equal to R equals to 5 units. So R square is 5 square, 5 square is 25, so here we have 25 pi, 100 degrees over 360 degrees is 1 over 3, so it is 25 pi over 3 square units. Okay, so the area of sector AQB equals to 25 pi over 3 square units. Likewise, the area of sector APB will be equal to pi r square times 120 degrees over 360 degrees, and it is exactly the area of sector AQB, that is to say, the area of sector APB will be equal to 25 pi over 3 square units. So we found out that the area of sector AQB equals to the area of sector APB. Likewise, the area of triangle AQB, will be equal to the area of triangle APB. Okay, the area of those two triangles will be equal to each other. Why? Because of the fact they can go into each other, therefore they have also the same areas. So in conclusion, we found out that the area of sector AQB equals to the area of sector APB, and the area of triangle AQB equals to the area of triangle APB. Okay, so if we subtract the area of sector AQB, if from the area of sector AQB we will subtract the area of triangle AQB, we will get segment APB. Okay, the area of sector AQB minus the area of triangle AQB will be equal to the area of segment APB. Segment APB. Okay, this is segment APB. Likewise, the area of sector APB minus the area of triangle APB will be equal, again, the area of sector APB. This is sector APB minus the area of triangle APB will give us the area of segment AQB. Segment AQB. And the area that we are looking for is the area of segment APB plus the area of segment AQB. Okay? So if we define the area of sector AQB as X, and we will define the area of sector of triangle AQB as Y, then the area of segment APB will be equal to X minus Y, but because of the fact that the area of sector AQB equals to the area of sector APB, then the area of sector APB will be also equal to X, and the area of triangle APB equals to the area of triangle AQB, and the area of triangle AQB is Y. Therefore, the area of triangle APB will be also equal to Y because of the fact that the area of triangle APB equals to the area of triangle AQB. So we found out that the area of segment AQB will be also equals to X minus Y. And again, the area that we are looking for is the sum of the areas of segment APB plus segment AQB. But they have the same areas. So we will find out the area of one segment, that is to say the area of segment AQB, we will multiply it by 2 and we will get the area that is required. Okay? That is actually the green area. Okay? So the area of sector APB, the area of sector, so we will do the area of sector AQB, that is actually 25 pi over 3. The area of sector AQB is 25 pi over 3 square units minus the area of triangle AQB. The area of triangle AQB, we will find out what is the area of triangle AQB. So we will have to multiply the area of sector AQB minus the area of triangle AQB by 2 in order to get the required area. And we have already found out that the area of sector AQB equals to 25 pi over 3 square units. The only thing that is left to do is to find out the area of triangle AQB. Okay? What is the area of triangle the area of triangle AQB? The area of triangle AQB will be equal to the area of this triangle AQB will be equal to the base of the triangle that is actually AB times the height of the triangle that is actually MQ divided by 2. I repeat again, the area of triangle AQB will be equal to the base of the triangle that is actually AB times the height that is actually MQ divided by 2. Here we'll have to divide it only one time by 2. It is the base times the height over 2. The base is AB, the height is MQ over 2. So AB, what is the value of AB? So here we have sinus 60 degrees equals to, we will define AM as age over 5 in triangle AMQ sinus 60 degrees equals to age, it is actually AM over AQ AM is age, is the missing variable, AQ is 5. So we found out that sinus 60 degrees equals to age over 5. Here we will multiply the equation by 5. And sinus 60 degrees is square root of 3 over 2. So square root of 3 over 2 times 5 equals to age. That is to say, age equals to square root of 3 over 2 times 5. In the same way, we will get that if we focus on triangle QMB, if sinus 60 degrees will be also equal to age over BQ, we get the same results for MB. Okay? If we focus on triangle QBM, here sinus 60 degrees will be equal to MB over BQ, that is 5 degrees. Therefore MB will be also equal, that is age, to square root of 3 times 5 over 2. Therefore the height AB will be equal 2 times age, because AM equals to MB. So AB will be equal to 2h, that is to say it will be equal to 2 times square root of 3 times 5 over 2. So here 2 over 2 is 1. So we got that AB equals to square root of 3 times 5. AB equals to square root of 3 times 5. And again, the area of triangle AQB is AB, that is actually square root of 3 times 5 times MQ. MQ is 5 over 2, all divided by 2. That is to say, 5 times 5 is 25 times square root of 3 over 4. So we found out that the area of triangle AQB equals to 25 times square root of 3 over 4 square units. Okay, so here we will substitute the area of triangle AQB by 25 times square root of 3 over 4. That is the area that we found for triangle AQB. And we get that the required area equals to 2 times 25 pi over 3 minus the area of triangle AQB, that is actually 25 times square root of 3 over 4 square units. Therefore, the required area will be equal to, here we will take 25 as a common factor out of these two expressions, and we will get that the required area will be equal to 2 times 25, and inside the brackets from this expression, what is left after we took 25 a common factor from it, what is left is pi over 3 minus, so we took from this expression 25 as a common factor, and what is left from it after we took from it 25, what is left from it is square root of 3 over 4. So we actually found out that the required area equals to 2 times 25 is 50 times pi over 3 minus square root of 3 over 4 square units. Okay, I'll repeat again. The green area equals to 50 times pi over 3 minus square root of 3 over 4 square units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. So here we will define the center of this circle as P. We define the center of this circle as Q. We define the intersection point between the two circles as point A. And we define the intersection point between those two circles, the second intersection point between those two circles as point B. we'll join together points A and Q, A and P and B, P and Q. We know that AQ equals to 5 units. It is the radius of the circle. AP also equals to 5 units like we did in the first method. And PQ, we have already found out that the first method that PQ also equals to 5 units. And here, when we have an equilateral triangle, that is to say, here, triangle APQ is an equilateral triangle, that is to say, all its angles will be equal to 60 degrees. Likewise, we will join points P and B together by a straight line. PB equals to 5 units. We will join points Q and B by a straight line. QB will be also equal to 5 units. So we can see here that triangle PQB is also equilateral triangle. That is to say, all of its angles will be equal to 60 degrees. And it is very easy to see that those two triangles can join to each other. I'll write it down. Triangle APQ, the equilateral triangle APQ can join to the equilateral triangle PBQ. According to side rule. According to side rule. So actually the green area is equal to the areas of triangle APQ plus the area of triangle PBQ. They will have the same areas because they are congruent to each other. So the area of those two triangles is 2 times the area of these two equilateral triangles will be equal to the area of the equilateral triangle, 2 times the area of the equilateral triangle APQ, because of the fact that those two triangles can congruent to each other, they have also the same areas. So the area of triangle APQ plus the area of triangle PBQ will be equal to 2 times the area of triangle APQ. So the required area is 2 times the area of the equilateral triangle APQ plus segment AQ, plus segment BQ plus segment PB plus segment AP. Okay, so the sum of those two equilateral triangles plus the sum of the areas of the four segments will be equal to the area or to the shape, to the green area. Okay, so I repeat again, the required area will be equal to 2 times the area of triangle APQ plus the area of segment AQ plus the area of segment BQ plus the area of segment PB plus the area of segment AP. Okay. So, what is the area of triangle APQ? We will draw perpendicular from point A to PQ, and we define the touching point between the perpendicular from point A to PQ as point M. So we will have here 90 degrees, and we will define AM as H, and we will get that in triangle AMQ, sinus 60 degrees equals to H over AQ but AQ, so it is H over AQ is 5 units, so in triangle AMQ sinus 60 degrees equals to H over 5, and sinus 60 degrees is square root of 3 over 2, so we'll substitute sinus 60 degrees by square root of 3 over 2, and it equals to H over 5. Here we will multiply this equation by 5, and we will get that H equals to square root of 3 times 5 over 2. So the height of triangle APQ equals to H, that is square root of 3 times 5 over 2, and the area of triangle APQ will be equal to the base of the triangle that is actually PQ. The area of triangle APQ will be equal to the base of the triangle that is actually PQ times the height that is H over 2. Okay, the area of triangle APQ equals to PQ, that is the base, times the height over 2. But PQ is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point P, and ends at point Q, that is a point of the circle itself. Therefore, PQ equals to 5 units. So it is actually 5 times the height and the height h equals to square root of 3 times 5 over 2, all divided by 2. So we found out that the area of triangle APQ equals to 5 times 5 times square root of 3 over 2 times 2, that is to say 5 times 5 is 25, times square root of 3 over 2 times 2 is 4. So the area of triangle APQ equals to 25 times square root of 3 over 4 square units. And the required area is 2 times the area of triangle APQ plus 4 times the area of segment AQ plus the area of segment BQ plus the area of segment PM plus the area of segment AP. Okay? But what is the area of segment AQ? The area of segment AQ the area of this segment AQ is equal to the area of sector APQ, the area of this sector, minus the area of triangle APQ. I'll repeat again. The area of segment AQ equals to the area of sector APQ minus the area of triangle APQ. And the area of segment AQ, so the area of segment AQ equals to the area of sector APQ. The area of sector APQ equals to pi r square times 60 degrees over 360 degrees. Again, the area of sector APQ equals to the area equals to pi r square times 60 degrees over 360 degrees. Here r equals to 5, so r square is 25. So we get here 25 pi, 60 degrees over 360 degrees is 1 over 6. So we found out that the area of sector APQ equals to 25 pi over 6 square units. And the area of triangle APQ, the area of triangle APQ we have already found out that the area of triangle APQ is equal to 25 times square root of 3 over 4 square units. So we know that the area of sector APQ is 25 pi over 6, and the area of triangle APQ is 25 times square root of 3 over 4 square units. So in conclusion, we get that the area of segment AQ equals to the area of sector APQ, that is actually 25 pi over 6, minus the area of triangle APQ, that is actually 25 times square root of 3 over 4. That is actually the area of segment AQ. And the required area equals to 2 times the area of triangle APQ plus the area of segment AQ plus the area of segment BQ plus the area of segment PQ plus the area of segment AP. But you can see here that the area of segment AP will be exactly equal to the area of segment AQ. Why? Because I will show it now. The area of segment AP, the area of segment AP the area of segment AP will be equal to the area of sector APQ minus the area of triangle APQ. And it is exactly the same equation as the area of segment AQ is also the area of sector APQ minus the area of triangle APQ. So they have the same areas. Segment AQ and segment AP equals to the 25 pi over 6 minus 25 times root of 3 over 4. Okay, they have the same areas. Segment AP and segment AQ equals, they are equal. They have the same areas. And the area of segment PB, what is the area of segment PB? The area of segment PB it will be equal to the area of sector QPB, the area of sector QPB minus the area of triangle PQB. And the area of sector QPB will be equal to pi r squared times 60 degrees over 360 degrees. The area of sector QPB equals to pi r squared times 60 degrees over 360 degrees, exactly as the same area of sector APQ. And the area of triangle PQB equals to the area of triangle APQ, because they are congruent to each other. Okay, again, the area of sector APQ equals to the area of sector QPB. There, it is exactly the same area, and the area of triangle APQ equals to the area of triangle PQB because they are congruent to each other. So we found out that the area of segment PB equals to the area of segment AP, that is also equals to the area of segment AQ. Okay, and then what is the area of segment QB? The area of segment QB will be equal to the area of sector PQB minus the area of triangle PQB. Okay, I repeat again, the area of segment QB equals to the area of sector PQB minus the area of triangle PQB, exactly the area, exactly the same area of segment PB. That is actually sector QPB minus the area of triangle PQB. So, in conclusion, we found out that the areas of the four segments AQ, AP, PB, and QB are equal. Therefore, we can multiply the area of segment AQ 4 times, and we will get the area of segment AQ plus the area of segment AP plus the area of segment PB plus the area of segment QB. Okay? So, the required area will be equal to will be equal to 2 times the area of triangle APQ plus 4 times the area of segment AQ. Okay, the sum of the areas of those two equilateral triangles plus 4 times the area of segment AQ will be equal to the area of this green shape, because of the fact that all 4 segments, segment AQ, segment AP, segment PB, and segment QB, have the same areas. So if we multiply the area of segment AQ by 4, we will get the sum of the areas of those 4 segments. Therefore, the area of this green shape will be equal to the area of those 2 triangles, but because of the fact that those 2 triangles can go into each other, those 2 equilateral triangles can go into each other, they have also the same areas. So we can multiply the area of this equilateral triangle APQ by 2, and we get the areas of those 2 triangles. plus 4 times the area of segment AQ will give us the area of this green shape. Okay, so we have already found out that the area of triangle APQ equals to 25 times square root of 3 over 4. So we must multiply the area of triangle APQ by 2 in order to get the areas of those two equilateral triangles. That is the same area. So 2 times the area of triangle APQ plus 4 times the area of segment AQ, that is actually the area of segment AQ. We've already found out that the area of segment AQ equals to 25 pi over 6 plus 25 square root of 3 over 4. Okay, so actually this expression is the required area. Here we will divide this expression by 2, so here we will have 2 will get cancelled, and here 4 over 2 is 2, so we will have here 25 times square root of 3 over 2 plus 4 times 25. Here we will have here 100 times pi over 6 plus 4 times 25 is 100 times square root of 3 over 4. So here we will divide this expression by 2, and we get that here we have 50 pi over 3 plus 100 times square root of 3 over 4, and here we will multiply both the numerator and the denominator of this expression. It is actually, here is minus, so here is also minus. Okay, here we will multiply both the numerator and the denominator by 2, and we will get that this is actually 50 times square root of 3 over 4 plus, so this is the required area. Here 100 times square root of 3 over 4 minus 50 times square root of 3 over 4 will give us 50 times square root of 3 over 4 minus 50 pi over 3. Here we take 50, we take out 50 as a common factor out of those two expressions, and we'll get that the required area will be equal to 50. So 50 was taken out as a common factor, and inside the brackets we will have square root of 3 over 4 minus pi over 3 square units. Okay, so we actually found out that the area of the green shape, or the green area, equals to, in the second method we found out, exactly as we found out in the first method, that the green area equals to 50 times square root of 3 over 4 minus pi over 3 square units. Okay? So now I will summarize the lecture. here we have two circles, and each circle passing through the center of the other circle. This circle passing from point Q, that is the center of this circle, and this circle passing from point P, that is the center of this circle. And we know that the radius of both circles are equal to 5 units, and we want to find out the area of this green shape. Okay? And first of all, we join together points A and P by a straight line, points A and Q by a straight line. We join together points B and Q by a straight line, and point P and B by a straight line. And here AP equals to AQ equals to QB equals to PB, and they are actually the radiuses of those two circles, all four of them. Therefore, we actually created here a rhombus, and then we join together points A and B and points P and Q. AB and PQ are the diagonals of rhombus APQB. And we know that the diagonals of a rhombus bisect each other, and they are perpendicular to each other. Okay? I'll repeat again. The diagonals of a rhombus bisect each other, and they are perpendicular to each other. So here, therefore, the diagonals bisect each other. It means that here PM must be equal to MQ, and also AM equals to MB, and they are perpendicular to each other. That is to say, we have here 4 right angles. This is the characteristics of a rhombus. We know here that PQ is the radius of this circle, therefore it also equals to 5 units. And because of the fact that the diagonals bisect each other, it means that PM equals to QM, PM equals to QM, because of the fact that the diagonals bisect each other. So if we define QM as X, then PM will be also equal to X, and we also know that PQ equals to 5. So PM plus QM equals to PQ, PM plus MQ equals to PQ. But we know that, so PM plus MQ equals to PQ, but we know that PQ equals to 5. But PM equals to X, according to our definition. QM also equals to X. X plus X is 2X, and so we got that 2X equals to 5. If we divide this equation by 2, we'll get that X equals to 5 over 2. Okay, we got here that X equals to 5 over 2, that is to say PM equals to 5 over 2, and MQ that equals to X also equals to 5 over 2. Okay? Then in triangle AMQ, this triangle AMQ, we know that here cosinus, we define this angle as theta. Cosinus theta equals to PM over PA, or if we focus on triangle AMQ, this is actually triangle AMQ. In this triangle AMQ, cosinus theta equals to QM over AQ. In triangle AMQ, cosinus theta equals to QM over AQ, but QM equals to 5 over 2. MQ, AQ equals to 5. So we got that cosinus theta equals to 5 over 2 over 5. Here 5 over 5 is 1, so we found out that cosinus theta equals to 1 over 2. So if cosinus theta equals to 1 over 2, it means that theta equals to 60 degrees. Okay, so we found out that this angle theta equals to 60 degrees. And so this is in triangle AMQ, and if we do the same process here in triangle PMB, this triangle here, cosinus theta will be equal to PM over PB, and PM equals to 5 over 2, PB equals to 5, so we get also that theta equals to 60 degrees, and the same thing we get here that cosinus theta equals to 5 over 2 over 5. That is to say, theta will be equal to 60 degrees. So in all four right triangles, we'll get that theta equals to 60 degrees, because they have the same sides. The length of one side, the angle that is the side that is near angle theta is 5 over 2, and the hypotenuse is 5. Therefore, we get that cosinus theta equals to 1 over 2, and therefore theta will be equal to 60 degrees. So in all four right angles, angle theta, this angle will be equal to 60 degrees. Okay, and then we actually proved that triangle AQB can go into triangle APB. Why those two triangles can go into each other? First of all, we know that AP equals to AQ equals to 5 units. AP equals to AQ equals to 5 units. We also know that PQ equals to QB equals also to 5 units. PQ equals to QB equals also to 5 units. And AB is a common side, it belongs to both triangles, so AB equals to AB. It's a common side. AB equals to AB is a common side. Therefore, we actually proved that triangle AQB can go into triangle APB according to side rule. Okay? So those two triangles can go into each other. Then we calculated the area of sector AQB. The area of this sector AQB. What is the area of this sector AQB? It will be equal to pi r squared times 60 plus 60 is 120 degrees over 360 degrees. The area of sector AQB equals to pi r squared times 180 degrees over 360 degrees. R equals to 5 units, therefore r squared is 25. So it is 25 pi, and 120 degrees over 360 degrees is 1 over 3. So in conclusion, we found out that the area of sector AQB is equal to 25 pi over 3 square units. Likewise, we found out that the area of sector APB, the area of this sector APB, equals to pi r squared times 60 degrees plus 60 degrees over 360 degrees. So the area of sector AQB, it has the same expression, pi r squared times 120 degrees over 360 degrees. So it is also the same areas. So the area of sector APB equals to the area of sector AQB. And the area of triangle APB also equals to the area of triangle AQB. Okay? Therefore, I repeat again, we actually found out that the area of sector AQB equals to the area of sector APB. And the area of triangle AQB equals to the area of triangle APB. And what is the area of segment APB? The area of segment the area of segment APB, it is actually the area of segment APB will be equal to the area of sector AQB minus the area of triangle AQB. Again, the area of segment AQB equals to the area of sector AQB, the area of segment AQB equals to the area of sector APB minus the area of triangle APB, and the area of segment APB equals to the area of sector AQB minus the area of triangle AQB. You can see it from the drawing. Here we have sector AQB. If we subtract from sector AQB the area of triangle AQB, we will get half of the segment that is required, that is segment APB. And if we subtract from sector APB the area of triangle APB, we will get half of the segment, half of the area that is required, that is the area of segment AQB. And the area of segment AQB plus the area of segment APB, it is exactly the area of the green shape. Therefore, but because of the fact that the area of sector AQB equals to the area of sector APB, and the area of triangle AQB equals to the area of triangle APB, we get that the subtraction of sector, the area of sector APB, AQB minus the area of triangle AQB, that is actually we will get that segment APB, the area of segment APB is equals to the area of segment AQB. Why? Because the area of sector AQB equals to the area of sector APB. So if we define the area of sector AQB is x, then the area of sector APB will be also equal to x. And if we define the area of triangle AQB as y, then the area of triangle APB will be also equal to y, because of the fact that they are congruent to each other. Therefore, the area of segment APB will be equal to x minus y, and the area of segment AQB will be also equal to x minus y. Therefore, we can calculate the area of one segment, and we will multiply it by 2, and we will get the required area, that is actually the area of the green shape. Okay? Again, the area of sector AQB minus the area of triangle AQB will give us the area of segment APB, that is half of the area that is required. And the area of sector APB minus the area of triangle APB will give us the second half segment, the half of the area, the half of the area that is required. This is actually the area of segment AQB. Therefore, we can actually calculate the area of one segment. We'll multiply it by 2 and we'll get the area that is required. It is actually the area of the green shape. Okay, so the required area will be equal to 2 times the area of 2 times the area of segment AQB, and the area of segment AQB equals to the area of sector, or it is actually the area of segment APB, that is actually the area of sector AQB minus the area of triangle AQB. Okay, so the area of triangle AQB, or the area of sector AQB minus the area of triangle AQB, will give us the area of segment APB, and if we multiply the area of segment APB by 2, we will get the required area that is actually the area of the green shape. Okay, so we multiply the area of segment APB by 2, we multiplied by 2. We actually already found out that the area of sector APB equals to 25 pi over 3 minus the area of triangle AQB, that is 25 pi over 3 times 2 will equal to the area of the green shape. Okay? And again, the area of triangle AQB equals to the base of the triangle, that is AB, times the height, that is MP, over 2. The base AB times the area that is actually the area of triangle AQB. This triangle equals to the base of the triangle, that is AB, times the height, that is AQ, times 2. AB times MQ over 2. AB, what is the area of AB? The length of AB is sinus 6, if we focus on one of these triangles, sinus 60 degrees will be equal to h over 5. Sinus 60 degrees equals to h over 5 in triangle AMQ. And sinus 60 degrees is square root of 3 over 2. So we multiplied the equation by 5, and we got that h equals to square root of 3 over 2 times 5. Okay, h equals to square root of 3 times 5 over 2, and here we get the same result for MB, because it is actually sinus 60 degrees will be equal to MB over 5. Therefore, AM equals to MB. Okay, AM equals to MB, so we can multiply h by 2 in order to get the value of the length of AB. So we multiplied h by 2, and we got that AB equals to square root of 3 times 5. Therefore, the area of triangle AQB, equals to the base, that is actually square root of 3 times 5, times the height, that is 5 over 2, and again the height AB equals to square root of 3 over 5 times the height, that is 5 over 2, all divided by 2. 5 times 5 is 25. 25 times square root of 3 over 2 times 2 is 4. So the area of triangle AQB equals to 25 pi over 4 square units. Okay, that is the area of triangle AQB. then we actually have to multiply the area of triangle AQB by 2. The required area is the area of triangle AQB. It is actually the area of triangle AQB minus or the area of sector AQB minus the area of triangle AQB multiplied by 2. The area of sector AQB is 25 pi over 3. The area of triangle AQB is 25 times square root of 3 over 4. We have already found out that the area of triangle AQB equals to 25 times square root of 3 over 4 square units. So the area of the sector minus the area of the triangle equals to the area of the segment, that is half of the area that is required. And if we multiply the area of segment AQB by 2, we will get the area that is required. So we multiplied the area of the segment by 2 and we got the area that is required. Okay, so here we took 25 out as a common factor out of this expression. So 25 is taken out as a common factor, and inside the bracket what is left, it is actually pi over 3 minus square root of 3 over 4. 2 times 25 is 50. So in conclusion, we got that the area of the green shape equals to 50 times pi over 3 minus square root of 3 over 4 square units. Okay, so we finished with the first method. In the next step, I will show you how we found out the area of the green shape according to the second method. In the second method, we join points A and P, A and Q, P and B, Q and B by a straight line, and all of these line segments are the radiuses of those two circles that is to say they are equal to 5 units. And then we join points P and Q by a straight line. PQ is also the radius of this circle, that is to say it equals to 5 units. So here we created two equilateral triangles. Triangle PAQ is an equilateral triangle because of the fact that all of its sides are equal to 5 units. And triangle PQB is also an equilateral triangle because of the fact that all of its sides are also equal to 5 units. Okay. Then those two equilateral triangles, they are congruent to each other because of the fact they have the same sides. According to side rule, we'll get that those two triangles congruent to each other, therefore they also have the same areas. So triangle APQ congruent to triangle PBQ according to side rule, and the required area will be equal to the sum of the areas of those two equilateral triangles plus the area of the areas of the four segments, segment AQ plus segment BQ plus segment PB plus segment AP. Again, the required area, and because of the fact that those two triangles can go into each other according to side rule, we can calculate the area of one triangle and multiply it by 2, and we will get the area of those two triangles. Okay, because they have the same areas, so it is the required area will be equal to 2 times the area of the equilateral triangle APQ plus the sum of the areas of the four segments, segment AQ plus segment BQ plus segment PB plus segment AP. Okay, so we got the area of triangle AQP. What the area of triangle? We found out the area of triangle AMQ. Actually, here we have in triangle AMQ, we know that sinus 60 degrees equals to h over 5. Sinus 60 degrees equals to h over 5. And sinus 60 degrees is equal to 3 over 2. So it equals to h over 5. We multiplied this equation by 5 and we got that h, that is AM, that equals to h equals to square root of 3 times 5 over 2. And the area of triangle APQ, the area of the equilateral triangle APQ, will be equal to the base of the triangle, that is PQ, times the height over 2. Again, the area of triangle APQ equals to the base of the triangle, that is PQ, times the height over 2. PQ equals to 5 units, it is the radius. Edge, we already found out that edge equals to square root of 3 times 5 over 2, all divided by 2. So here 5 times 5 is 25, so in the numerator we have 25 times square root of 3 over 4, and 25 times square root of 3, and in the denominator we have 2 times 2, that is 4. So in conclusion, we found out that the area of triangle APQ equals to 25 times square root of 3 over 4 square units. Okay? And now we have to find out the areas, so the sum of the 2 times the area of triangle APQ plus the sum of the areas of those 4 segments, AQ, QB, AP and PB will be equal to the area of this green shape. And we found out the area of segment AQ. What is the area of segment AQ? It will be equal to the area of sector PAQ minus the area of triangle PAQ. Okay, the area of segment AQ will be equal to the area of sector APQ minus the area of triangle APQ. The area of sector APQ equals to 25 pi over 6. Here, why? Because the area of sector APQ, it is pi r square times 60 degrees over 360 degrees. The area of sector APQ is pi r square times 60 degrees over 360 degrees. R equals to 5, so r square is 25. So in the numerator we have 25 pi over 6, because 60 over 360 is 1 over 6. So in conclusion, we found out that the area of sector APQ equals to 25 pi over 6 square units. And the area of triangle APQ, we already found out that the area of triangle APQ equals to 25 times square root of 3 over 4. So in conclusion, the area of segment AQ equals to 25 pi over 6 minus 25 times square root of 3 over 4 square units. Then we calculated the area of segment AP. What will be the area of segment AP? It will be equal to the area of sector APQ. Here, the area of sector AP will be equal to the area of sector APQ. Again, the area of segment AP will be equal to the area of sector APQ. The area of this sector minus the area of triangle APQ. Again, the area of sector APQ minus the area of triangle APQ will be equal to the area of segment AP. The area of sector APQ minus the area of triangle APQ will be equal to the area of segment AP. So the area of segment PB, what will be the area of segment PP? PB, the area of segment PB will be equal to the area of sector QBP minus the area of triangle QBP. Okay, the area of sector BB will be equal to the area of segment PB will be equal to the area of sector QPB minus the area of triangle PQB. The area of sector QPB, what is the area of sector QPB? It has here 60 degrees and the same radius, so it will be the same area as of the other sectors. Okay? It will be pi r squared times 60 degrees over 360 degrees, exactly like the area of sector APQ or the other sectors, minus the area of triangle APQ. Okay? But because of the fact that the area of triangle APQ equals to the area PQB, and the areas of those two sectors, the area of sector QPB also equals to the area of sector APQ. So we can write down here that the area of sector QPB minus the area of so here we got that the area of segment PB will be equal to the area of segment AP. Why? Because they have the areas of the sectors are the same areas, and here we have the triangle PQB is congruent to triangle APQ. Therefore, we will get that the area of segment PB will be equal to the area of segment AP. Then the area of segment QB will be equal to the area of sector PQB minus the area of triangle PQB. Okay, and they have also the same areas of the other segments. Therefore, we actually concluded that we can, in order to find out the area of the four segments, we'll multiply the area of sector AQ 4 times, and we will get the area of the four segments, because they have the same areas. So the required areas are 2 times the area of triangle APQ plus 4 times the area of segment AQ. The area of triangle APQ is 25 times square root of 3 over 4, and we must multiply it by 2 in order to get the area of those two equilateral triangles, plus the area of the four segments will be equal to this green area, but the area of the four segments are equal to each other. Therefore we will multiply the area of segment AQ by 4, and we will get the area of the four segments. So 4 times the area of segment AQ is 4 times, and the area of segment AQ equals to 25 pi over 6 minus 25 square root of 3 over 4. So here, we divided this numerator and the denominator by 2, and we got here 2 will get cancelled, and here 4 over 2 is 2. So in conclusion, we found out that this expression equals to 25 times square root of 3 over 2, and here 4 times 25 is 100, so here we get 100 pi over 6, and here we have 4 times 25 is also 100, so here we get minus 100 times square root of 3 over 4. Okay? 4 times 25 is 100, so here we get 100 times square root of 3 over 4, and here we have we multiplied both the numerator and the denominator by 2, and we got here 50 times square root of 3 over 4 plus 50 pi over 3 minus 100 times square root of 3 over 4. 50 times square root of 3 over 4 minus 100 times square root of 3 over 4 equals to minus 50. It is actually equals to minus 50, and here we have 50 pi over 3, so it is actually 50 pi. Here we have 50 times square root of 3 over 4 minus 50 times square root of 3 over 4 plus 50 pi over 3. Okay, again we have 50 pi over 3 minus 50 times square root of 3 over 4. So here we took 50 as a common factor, and we got that the green area equals to 50 times square root of 3 over 4 minus 3 over 4 square units. Okay, so in both methods we got that the green area equals to 50 times square root of 3 over 4 minus pi over 3 square units. Okay, thank you very much.